Okay, so because I'm gone, I have this great video for you guys. Sorry for being gone, but that's life. We're gonna start off here with a review of our arithmetic sequences. There were two different equations we talked about to help us solve these. One being, of course, let's try this again, come on. Okay. AN equals A1 plus the difference between n minus 1. Our other equation was AN equals A0 plus the difference with n. Both will get you the same answer. One's easier than the other, but this is the one on the left that they'll generally give you. Even though it's more work, you're smart enough to be able to work through it. So, things I need to know. The first number in my sequence, which in this case happens to be 5. And then I need to know my difference. So 5 to 6 plus 1, 6 to 7 plus 1, 7 to 8 plus 1. So my difference here is 1. I can go in, plug that in here. AN equals A1, which is 5, plus the difference of 1, and minus 1. I need to have that in simplest form, though, and in simplest form, you can't have parentheses. So I'm going to have to distribute the 1, which is easy because it's just the number 1. So our 5 doesn't get touched. We'll have a 1n minus 1. Combine like terms. AN equals 4 plus n. Okay, there were a lot of steps there to solve that. Over here, what I need to do is figure out my A0. So what that means is it's the number that would come before the first in our sequence. So I would have to do the reverse of my difference. So by going back one, we would have a 4 there. So this scenario would get us AN equals 4 plus our difference of 1n. Writing that simplified, we just get 4 plus n. Look, same answer, two different ways to solve it. One is much easier than the other. You just need to be able to break down those steps. So moving forward today, we're going to go over geometric sequences. So it's another sequence. It has a pattern, but it's in a different way. So I have for you here 3 geometric sequences, and I want you to think, looking at these, what is it that makes a geometric sequence? Just looking and thinking. You can pause if you want to think about it. You can tell there's a pattern. You just need to figure out what's happening. So what's happening? To get from 1 to 4, yeah, it's plus 3. But from 4 to 16, is it plus 3? No. So that's not going to work for us. 1 to 4, we can also times 4. 4 to 16 times 4. 16 to 64, is times 4. So in here, 3 to negative 3. Since the earlier one we were multiplying, I'm probably going to go with, okay, geometric sequence, we're multiplying and dividing, right? 3, negative 9, that's times negative 3. Negative 9 to positive 27 times negative 3. Positive 27 to negative 81, negative 3. So a hint for you. If your sequence is going positive, negative, it's probably being multiplied by a negative number. Okay? So if you're switching between positive and negative numbers all crazy like, that means your ratio here is a negative. 10 to 5. You're all going to want to say divided by 2, right? But when we're working with geometric sequences, we need to keep this in terms of multiplication. So dividing by 5 is the same thing as multiplying by 1/2. So we need to make sure that that's how we're taking this. Times 1/2 times 1/2. So whatever you do, if you were dividing by 4, remember that's the same thing as multiplying by 1/4. So just know how to switch it into multiplication if you just so happen to be dividing. So what makes a geometric sequence is it's a listing of numbers in a pattern that is being multiplied each time by a common ratio. So your ratio is the number that's being multiplied between each number in a sequence. So ratio is like super important to know that word. Just like difference was important with our arithmetic sequences, now we got a common ratio. So to figure out our common ratios, these ones are a piece of cake. 3 to 6, 6 to 12, 12 to 24, we're timesing by 2. So the common ratio is 2. Positive, negative, positive, negative, positive. I can know right away that my ratio is going to be negative because I see that pattern. And that pattern is consistent with having a negative ratio. Now to get from 1 to 1/2, that's dividing by 2, but I know that that means times 1/2. Times 1/2, times 1/2, and correction, it's negative 1/2. So our ratio is negative 1/2. And 1 to 5, 5 to 25, 25 to 125, I'm multiplying by 5 each time. So the ratio is 5. Pretty easy, right? When we can look and just see the pattern on our own. Well, just like before, sometimes it's not that easy. So here I've got 3 over 2, and then I get negative 1/3, and then I get 2/27, then I get negative 4 over 243. What the heck is happening? So just like the difference formula where we took A2 minus A1, it's very similar. We're taking A2 this time divided by A1 since a common ratio is multiplying instead of adding like the difference. So we're going to use this formula, A2 divided by A1, to find our common ratio. So with my sequences, we got the first one, we got the second one. So A2 is negative 1/3 divided by A1, which is 3 over 2. My rule is for fractions. Okay, fractions are so important. I know you guys hate them, but we're just going to have to learn to love them and embrace them. So we need to remember that dividing by a fraction is the same thing as multiplying by the reciprocal. So that means equals, why will you not write? Okay, that's supposed to be an equal sign. Negative 1/3. We're, instead of dividing by 3 over 2, we're going to multiply it by its reciprocal, which means we flip it. So 3 over 2 becomes 2 over 3. When we multiply, a negative times a positive is a negative. And when you're multiplying with fractions, you go straight across. So 1 times 2 is 2. 3 times 3 is 9. So my common ratio is negative 2/9. And I'm just going to do like a double check to make sure that's right. I can get this page to extend. So that means I'm going to make sure that when I times by negative 2/9, I'm going to get 2/27. So if I have negative 1/3 times negative 2/9, a negative times a negative is positive. Multiply straight across. 1 times 2 is 2. 3 times 9, 9, 18, 27. 2/27, that's what's up here. Boom. Our ratio is negative 2/9. We're not done with geometric sequences though. We just figured out how to find the ratio, which is one major piece of this, don't get me wrong. So we need to learn how to make this equation. So just like with our arithmetic sequences, I'm going to make a list here. So I have A1, A2, A3, how many do I have there? 4, and 5. So A1, is 3. Just straight up. A2 gets us 3. We need to figure out what's happening here. How do I get from 3 to negative 6? It's got to be multiplied by a negative, and it's 2. Negative 2. So 3 times negative 2 gets us negative 6. For A3, we'll have 3 times negative 2 and times negative 2 again to get us positive 12. 3 times negative 2 times negative 2 times negative 2 to get us negative 24. And 3 times negative 2, 2, 3, 4 equals positive 48. Okay, look at how messy that kind of got, though. I was like trying to count how many negative 2 is. Ugh, gross. I don't like it. So we're going to try to figure out a simpler way to write this. A1, A2, A3, A4. And I'm even going to give us an AN so we can try to write this formula. So with our arithmetic sequences, we needed to take our number and multiply it by however many times that number was there. This time, we have to do something different. A lot of you during our class discussion were trying to do what we're supposed to do here with arithmetic sequences. So think of something that somebody had said earlier that's like, oh, that's going to work here. It didn't work with adding, but it works with multiplication. If I have 1, 2, 3 negative 2s, so negative 2 showing up 3 times, negative 2 times negative 2 times negative 2, I can write that as 3 times negative 2 to the 3rd power, because there's 3 negative 2s. Here, I've got negative 2. 2 times. Here, I've got negative 2 1 time. And here, I've got negative 2 0 times. So, just like before, to figure out what that power number is, we need to compare that back to our term number. So I'm trying to compare this 4 and 3. 3 and 2, 2 and 1, 1 and 0. Otherwise, in all of the equations, the 3 times negative 2 there is consistent. It's the same for all of them. To get from 4 to 3, minus 1. Let's see if that pattern sticks. 3 to 2, minus 1, 2 to 1, minus 1, 1 to 0, minus 1. So you take the number of the term, so in this case it's n, and subtract 1 to figure out what your power is. So that would be the formula in this case. So what that means is the geometric sequence formula is AN equals A1 times R n to the 1. So the two things that need to get swapped out are A1 and R. So if my sequence will stick, whoa, crazy. If my sequence is 3, 6, 9, that's not right. I'm trying to do an arithmetic sequence there. Ah! Sorry, guys, but I'm not restarting this video. If my sequence, let's try this again, is 3, negative 6, positive 12, negative 24. There we go. I'm back on the boat here. I need to figure out my A1 and my R. So my A1, that's easy. That's the first number in the sequence. Whew, it's just given to us 3. Perfect. Now we need to figure out the ratio. So how am I getting from 3 to negative 6? Well, I know I'm multiplying by a negative. 3 to 6 is 2. Let's test it. Negative 6 times negative 2 is 12. 12 times negative 2 is negative 24. So our ratio is negative 2. Then all I have to do is plug those two things in. to this equation. So an equals 3 times negative 2 to the n minus 1. And that's my formula. If I wanted to know what the 50th number in the sequence is, I would go a to the 50 equals 3 times negative 2 to the 50 minus 1. Don't just go punching all this stuff into your calculator. Your calculator treats you wrong. It's not a very good, trustworthy mechanism. You need to break it down. So I'll have 850 equals 3 times negative 2 to the 49. I need to follow the order of operations. There's no parentheses, but there is an exponent. When I punch this into my calculator, I need to make sure that I'm putting a parentheses around the negative 2 to the 49th. Otherwise, what it does is it takes 2 to the 49th power and then just throws a negative sign on it. That's not what we want. So, super, super important to put those parentheses around the negative 2. So negative 2 to the 49th power. What happens is it's getting me a huge, crazy number that I don't know what it is. I don't need to write this down, so I'm going to put times on calc. I did this. It's like negative 5.62, blah, 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 blah. It's in scientific notation. 850. If this is sitting on my calculator right now, all I need to do is type in times 3 to give me my answer, which once again, this is in scientific notation, which is fine because I know how to understand scientific notation. So if I have negative 1.6, it's 88, so I'm going to put 9 times 10 to the 15th power. So that means it's a super big negative number. If I want you to write this without exponents, that means we've got 1.69. And we need to move this over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And fill all those in with zeros. And that's what number comes next in this sequence. Okay, so all you have to do is plug in the number of the n into the formula and solve. I'll have the practices for you posted in Classroom. Because I'm gone, rely on one another to help you out. I will try to be available via email, but I cannot guarantee everything that I will be there. So rely on one another. Do your best. Email me with questions. I will get back to you at some point. And good luck with your geometric sequences.